This is a unit circle type question. The work I would expect is quadrant and reference angle on any of these. So we have secant 5 pi over 6. So what quadrant is 5 pi over 6 in? Reference angle, if you're in radians, all you have to do is ignore the top. So that's just pi over 6, which is 30 degrees. If you like to think about that. Secant is the reciprocal of cosine. In quadrant 2, is cosine positive or negative? Negative, so secant would be negative. Cosine of pi over 6, or the cosine of 30 degrees, is so secant would flip it. So 2 over radical 3, get your radical off the bottom. So it's negative 2 radical 3 over. Have one there? Is that one okay? There it is. Alright, we usually didn't keep negative angles. If it was a negative degree, you added 360. If it's a negative radian, we add 2 pi. So negative 3 over 4 plus 2 would be 5 pi over 4. What quadrant is that in? Quadrant 3. Reference angle is pi over 4, which is like 45 degrees. So in quadrant 3, is cosine positive or negative? What's the cosine of 45 degrees? So this would give me negative 4 radical 2 over 2, which reduces to negative 2 radical 23. If you don't recognize any obvious identities, the best place is always just to start by putting things in terms of sine and cosine. So tangent is what? Cotangent is minus cosine, or we can just write that as cosine equals minus cosine. So if we distribute, when you multiply these, you get sine times cosine over sine times cosine. That's just 1. If you have the same thing on top of the bottom, that's 1. Minus sine divided by cosine times cosine. So the cosines would drop, and leave this with the sine. Do you guys see how I made it for that step, or do I need to show?
How did we get the right side?
So when you multiply these, you multiply the tops, you multiply the bottoms. So when I distribute this, we get sine x cosine x, bring out space. Divided by cosine x times 1 over cosine x. So in this first fraction, everything cancels, and that leaves us with 1. And this one, the cosines drop, just left us with the sine. Other questions? $25 is a proof. So remember, on the proofs, you know what the final answer is. You have to have the work to show me how you get there. So we box in one side. Which side would you prefer to box in? The right, I agree. So we have to get a common denominator if we want to add or subtract fractions. This has 1 minus cosine, so if we want to flip like the other, it needs 1 plus cosine. This has 1 plus cosine on the bottom, so it needs 1 minus cosine. So we multiply by the same thing on top and bottom to get that common denominator. To multiply these, we have to FOIL. So on the top, we get 1 plus cosine x and plus cosine x would be plus 2 cosine x. Plus cosine times cosine is cosine squared x. Denominator, if we FOIL, we get 1 plus cosine and minus cosine cancel. Minus cosine squared x. Minus. Second fraction we FOIL, so we get 1 minus 2 cosine x plus cosine squared x over 1 minus cosine squared x. What do we do with the negative? So positive 1 and negative 1 cancel. Cosine squared and negative cosine squared cancel. 2 cosine x plus 2 cosine x is 4 cosine x. What is 1 minus cosine squared x? Sine squared x. Does everyone see how I made that leap there? We're actually really close to the end. Sine squared just means sine times sine. So we have a 4. Cosine over sine is cotangent. And then this is like a 1 over sine, which is cosecant x. So that gives us what we wanted. Then we get into the graphing. So, you got to remember some things about your graphs. I think question 39, I just told you make sure you can draw all 6 graphs, so you can draw a rough sketch of all of them there if you want. I think on 39 I also said be able to give the domain and range. I'm not just going to specifically ask you to give me all the domains and ranges, but if you're looking at a graph, you should be able to give those things by looking at the graph. And we also know sine and cosine can only fall between what values? Negative 1 and 1. That's something that's came up a lot, so I might put a question on there about that. When we are graphing these things, there's a list of information that I asked you to find. So I told you a lot of this final is going to be multiple choice. The graphing is probably not, because you kind of have to know what the graph looks like, and really these are hard multiple choice questions. It's easier if you actually have to list out everything and figure it out yourself. Okay, so we are graphing y equals 3 cosine of 2x minus 5. So what is our amplitude? Where do we look for the amplitude? The coefficient, the number in front of our trig function. So my amplitude is 3. Normal period. So sine, cosine, secant, and cosecant all have a normal period of what? 2 pi. To get your current period, you have to take the normal period divided by the coefficient on x. So that would be 2 pi over 2, which is just pi. How do you get the count by? Whatever you get for your period, divided by 4 for the 4 quadrants. So we're counting by 5 or 4. Interval. Sine, cosine, secant, and cosecant all typically start at 0 and end at 2 pi. You take your entire argument, the 2x minus pi over 3, and put that in the middle. And now we want to solve for x. So we would have to add pi over 3 to each end. So we get pi over 3 less than or equal to 2x less than or equal to 2 plus 1/3. So that would be 7 pi over 3. How do you get rid of your 2? Divide by 2 or multiply by 1/2. So we get pi over 6 less than or equal to x less than or equal to 7 pi over 6. So now we draw the graph. My amplitude is 3, so that means my high point is positive 3, my low point is negative 3. I'm starting at pi over 6. We always had 5 total points. How do we get the remaining points? Right, you add your count pi. So pi over 6 plus pi over 4, or 1/6 plus 1/4. So that would be 5 pi over 12 plus 1/4 would be 8 pi over 12, so 2 pi over 3 plus 1/4, so 11 pi over 12 plus 1/4 would be 14 pi over 12, so 7 pi over 6. And what do you notice about that final point? Yeah, it's the end of my interval, and that should always be the case. So now, how does the graph of cosine start? High point. So at my first point in my interval at pi over 6, we should be at our amplitude of 3. And it comes down to its 0 mark, down to its lowest point, and back up. If I asked you to do 2 periods, what would you do? Keep adding your count by to get 4 more points. You could do your second period. All right. 27. Negative 2 minus 3 tangent x. If you prefer, you could write this as negative 3 tangent x minus 2. What does the negative in front do? What does the minus 2 do? Okay. So our amplitude is the amplitude is just positive, so we'll just say 3. Period. Tangent and cotangent are different. The other trig functions all have a typical period of 2 pi. Tangent and cotangent just have a period of pi. So it's just pi divided by the coefficient of x, which is just 1, so we get pi. Count pi, we still do the period divided by 4, so we're going to count by pi over 4. Interval. Remember, tangent and cotangent are weird. Remember sine, cosine, secant, and cosecant. Their interval is from 0 to 2 pi. Tangent, we go from negative pi over 2 to positive pi over 2. What's the interval for cotangent? 0 to pi. And the reason we have those weird intervals for tangent and cotangent is because that way they start and stop at the asymptotes. So we just have one complete graph in between. So we are going to set this up from negative pi over 2 less than or equal to, it's just an x, less than or equal to pi over 2. So now we draw a graph. We are going down 2. So go to negative 2 and draw in an asymptote. Or not really even an asymptote, our center line. Our amplitude is 3, so we will go 3 above, which would take us to positive 1, and 3 below, which would take us to negative 5. We are starting at negative pi over 2. Negative pi over 2 plus pi over 4 is negative pi over 4. Plus pi over 4 is 0. Plus pi over 4 is pi over 4. Plus pi over 4 is pi over 2. Okay, so then we know we have vertical asymptotes on both ends. So tangent and cotangent, they both have asymptotes at the ends and 0 at the middle. Tangent is increasing, so it would start by going up. But what does the negative? Remember we said this one would flip. So it's actually going to start at its high point and go down. Good morning. How are you?
Do you want a flower arrangement from that?
Absolutely.
You just need the chart back.
Okay, thank you so much. So at this point we'd be at our amplitude of 3. And this one we are 3 below. And then just make sure when you draw these in, I know it's tricky sometimes, but make sure they're like kind of curved. It's getting closer to your asymptote as time goes on.